This video will cover counting significant figures. If you haven't watched the significant figure overview video, I suggest you start there. Recall that significant figures are all of the digits that are known and the first digits that's uncertain. And so as we're doing calculations, we may be asked to count the number of significant figures or determine the first uncertain digit or last significant figure. The rules for doing this are fairly simple. First, any non-zero digit, any number 1 to 9, will always be significant. In this number, the 8 and the 1. Zeros are tricky. There's 3 kinds of zeros. The first kind of zero are leading zeros. Leading zeros are never significant. The second kind of zero are interior zeros. Interior zeros are always significant. The third kind of zeros are the tricky ones. These are trailing zeros. And trailing zeros can be significant or not significant depending on if there's a decimal point. So trailing zeros are significant if there's a decimal point. So in this number, there's a decimal point, they would be 0. If we look just at that number, there is not. So as we're counting significant figures, we're always going to start with the first non-zero digit, 1. Interior zeros, zeros between 2 non-zero digits, are always significant, so we'll keep counting those. 2, 3. We always count non-zero digits, 4. In this case, with my finger covering that first part, there is no decimal point. Trailing zeros, zeros after the last non-zero digit, are not significant with no decimal point. So 4 significant figures. If we go back to the original number, however, these leading zeros, numbers before the first non-zero digit, are never significant, but the presence of that decimal point makes these trailing zeros count, and we would continue numbering 5 and 6. So let's do a couple more numbers as practice. Start counting at the first non-zero digit, 1. This is an interior zero. It's between 2 non-zero digits, 2, 3. There are 3 sig figs. First non-zero digit. It's between 2 non-zero digits. It's interior. It's always significant. It's a non-zero digit. It counts. This is a trailing zero, and in this number there is no decimal point. If there is no decimal point, trailing zeros are not significant. This is 3 sig figs. First non-zero digit, 1. Interior 0, 2. The 6, a non-zero digit, is our third. This is a trailing zero, but now there's that decimal point. If there is a decimal point, you count trailing zeros. This one is 4 sig figs. Okay. So 1,000, first non-zero digit. These are trailing zeros. So no decimal point. They're not significant. This would be 1 sig fig. But I want to give you a little bit of caution that if this were part of a unit conversion, like say 1,000 grams is 1 kilogram, it would be a defined value. And anytime I see a 10 or 100 or 1,000, I sort of double check that, make sure I'm not looking at a defined value. Only measured quantities, or I suppose some calculated values, but calculated values that came from measured quantities have uncertainty and use significant figures. So if this were a definition, like a SI prefix conversion from grams to kilograms, we wouldn't discuss it having significant figures. Okay, on this number, this is scientific notation. In scientific notation, you look only at this first part. You don't pay attention to the times the 10 to the 3. So this is 1, an interior 0, 2, 3. Scientific notation is very valuable when we want to carefully describe the precision of a number because it will never have leading zeros and it will never have trailing zeros. It's only going to show, well, it will never have non-significant trailing zeros. It's only going to show the significant digits. So in this case, 3 sig figs. 106 pennies is an interesting case again. If those pennies are counted one at a time, it's a discrete value. There's specific allowed values, and there won't be a measurement uncertainty. If the pennies were estimated by weighing the pennies and knowing the average mass of a penny, then that would be a measured value because mass is a continuous variable. But in general, if you sat down and you counted out 106 pennies, we wouldn't talk about measurement uncertainty in those pennies, and so this would not have significant figures. Okay. So go ahead and check your understanding. Pause the video for a minute and answer this question. Okay, so first non-zero digit, the 0.0 don't count. 1, 2, that's an interior 0, 3, 4 for a non-zero digit. This is a trailing 0. We look to see if there's a decimal point. If there is a decimal point, it's significant. 5. The answer here is C.